Okay, what we're going to do these last couple of days of class is we are going to have a series of final exam review videos that you can watch. You can practice some problems to help you prepare you for your finals next week. So we're going to go back to the beginning of second semester when we talked about solving triangles. We'll go through graphs, we'll go through some of the analytic trig, vectors, polar, and finally our series and sequences. So if we go back to solving triangles, we really had two ways to do this. We have what we're called the law of sines and cosines. Now the law of sines was good when you had a couple pieces of information, when you had two angles and a side, or two sides and an angle where the angle was not between the two sides. The law of cosines was good when you had all three sides, or you had two sides and the angle in between them. So AAS, SSA, SSS, or SAS. So if we look at this first example, we have a triangle where I have one angle, two sides, but the angle is not between the two sides. So this is law of sines. So the law of sines, if you remember, said that the sine of angle A divided by side A was equal to the sine of angle B over side B, and the sine of angle C over little c, side C. So in this case, if I have angle A, we would say 20 is side A. We'd say 14 is side B, just because it's across from angle B. And then this would be side C. So I could find really any of this stuff I need to if I just plug in the information I have right now. I do not know what angle A is, so I would just leave that as A. I know what little a is, that's 20. I know what angle B is, that is 15 degrees. And side B is 14. I really don't know anything about C right now, so I'm just going to leave that blank. So the idea is we're going to solve for angle A. So it's a pretty simple process. We'll just simply multiply both sides by 20. So we get sine A equals 20 times the sine of 15 over 14. Now all of this stuff on the right side is just a number. It's just a bunch of numbers, so I could just plug that in the calculator and see what value it gives me. And what I'll get is I'll get the sine of A equals 0.3697. So now we know what the sine of A is. I could find A by taking the inverse sine of this ratio. So I'll say is the inverse sine of 0.3697. So that will tell me what angle A is. So that gives me 21.7 if I round to the nearest 10. 21.7 degrees. So that gives me angle A. So I can come up here and I can say, alright, well angle A is 21.7. Now obviously this is not drawn to scale because this doesn't look like a 21.7 degree angle, but we'll just go with it. There is cases in this, and this might be one of those cases where you can have multiple triangular solutions, but for our exam we'll just focus on one. So now angle C I can find pretty easily because I could just do 180 minus 21.7 minus 15, which is our other two angles. So that would give me the other angle, because of course all angles in a triangle always add up to 180. So that's going to give me 143.3. Now I can find side C because I have angle C. So I'll just take the same law of sine and I'll just plug in the B's and the 1C I know, and I'll be able to find side C. So again, sine B, B was 15. So sine of 15 over 20, or over 14, pardon me. I could use A too, it doesn't really matter. So sine 15 over 14 equals sine of angle C, which is 143.3 degrees, over side C, which I'd like to find. So now the easiest way, I think, is just to cross multiply these two. So I'll get C times the sine of 15 equals 14 times the sine of 143.3 degrees. So if I just put the sine of 15 in my calculator, I'm going to get 0.2588. So that's C times 0.2588. And if I put everything on the other side in, 14 sine 143.3, I'll get 8.37. So I can simply divide both sides by 2588 to get what side C is. So I get 32.32. So C is going to equal 32.33 if I round up. So that's the missing side. So now if I go back to my triangle, I know that this side is that 32.33. Now, since this was that angle side case, I could check for the other solution I want. All I'd have to check is if I take 180 minus that original angle I found of 21.7, if I do that subtraction, I get 158.3, which would actually be another answer I could put in here, because if I add that to 15, I'm not over 180. So I could put that angle here, I could find angle C, and I could do the same problem again, just using that new angle. But again, on the exam, you do not have to worry about that. Okay, let's look at this one over here, number 2. And this one, all I'm given is 3 sides. So I'm obviously in the side category, which gives me the law of cosine. Now, if you remember what the law of cosine said, the law of cosine said a squared equals b squared plus c squared minus 2bc times the cosine of angle A. And you really could do this for any of them. I put A, B, and C, but I could have B by itself. I could switch B and A. I could switch A and C. Doesn't really matter. But I put it that way. So side A is 9, so that's 9 squared. Side B in this case is 3. Side C is 8. Minus 2 times 3 times 8 times the cosine of A. So the most important thing in evaluating this is make sure we do it in parts. So I'll evaluate the 9 squared, I'll evaluate the 3 squared plus 8, and then I'll evaluate this product here. So 9 squared is 81, 3 squared plus 8 squared is 9 plus 64, which is 73, minus 2 times 3 times 8, which is negative 48 cosine of A. And it's very important the order you do this here to get it to come out correctly. I'll then subtract 73 from both sides. So that will cancel. This will give me 8 equals negative 48 cosine of A. And then I'll divide both sides by negative 48. So this will give me the cosine of angle A equals negative 8 over 48, which is negative 1/6. If you want to reduce it, don't actually have to reduce it. Because now to find the angle, I always will just take the inverse trig function of that ratio. So I'm going to do the inverse cosine of 1/6, which is going to be 80.4. So angle A is going to be 80.4 degrees. Okay, I'll go ahead and let you try B as an exercise. So you can try and see if you can get angle B. And then once you have B, angle C would be really simple. Okay, let's look at a word problem that you can kind of see how that would work. So this says points A and B are on opposite sides of the Grand Canyon. Point C is 200 yards from angle A. Angle B measures 87 degrees and angle C measures 67. What's the distance between A and B? So if I have these points on opposite sides of a Grand Canyon, so this is A and this is B, and we have point C somewhere else, we'll put it up here, which is 200 yards from 200 yards. That'll be important. So now I'll cross multiply. So I will get C times the sine of 87 equals 200 times the sine of 67. And then just like before, we'll just type these in our calculator. Sine of 87 is 0.9986. So this will be C times 0.9986 equals 200 sine 67, which if I just type that in, I'm getting 184.1. And so I'll just divide both sides by 0.9986. So if I do that, I get 184.4. And that would be in yards, because all the first distance is in yards. So from point A to point B, it would be 184.4 yards. Okay, the second big thing we're going to look at is how to graph sine and cosine functions. Now here we're trying to graph this function 3 over 2 sine 2x minus pi. Now the big thing we're going to do is we're going to come down here and we're first going to talk about some of these things that we've talked about before. So if you have a generic function, y equals a, sine or cosine, bx plus c plus d, then you can find these four things, the period, the amplitude, the phase shift, and the vertical shift, from this equation. So if you remember the period is always 2 pi divided by b. The amplitude is the absolute value of a. The phase shift is negative c over b. And the vertical shift is going to be the d at the end. So if we go up here and look at the equation we're given, 3/2 sine 2x minus pi, then we can find a lot of these things. Now b in this equation is 2, because that's the number in front of x. So the period would be 2 pi divided by 2. So that just gives me pi. So I know this thing will repeat every pi. Now the phase shift is c over b. Now c is the number afterwards, so it's negative pi in this case. So it's negative pi over, it's negative pi, because remember it's negative pi over 2, which is going to be pi over 2. Now the amplitude is the number in front, which is just the absolute value of 3 over 2, which is just 3 over 2. And the vertical shift is going to be the number added at the end, which if you recall in this case, there were none. Because if you look at the end of the equation, there's no number there. So with this kind of information, I can kind of graph it. The only other important thing to remember is sine starts at 0. Cosine, it typically starts at A. So whatever A is, so it'll start at the amplitude. So, in this case, it's going to be a period of pi. That means it's going to repeat every pi units. And the phase shift is pi over 2, so I'm going to start the graph at pi over 2. Now you'll notice that everything on this graph is pi over 12. So this is 1 pi over 12, 2 pi's over 12, 3, 4 pi's over 12, 5, 6 pi's over 12. So this is actually where pi over 2 is, because 6 over 12 is pi over 2. So that's where we're going to start the graph, because it starts at the phase shift. And in this case, it's a sine wave, so it is going to start at 0, or in this case, it's going to start at the phase shift, wherever that is. So it's going to start at pi over 2. Now this is going to kind of go in force, because we're going to go basically 1 pi unit from this, because the period is pi. So if I take pi over 2, which is my phase shift, and I add pi to it, I'm going to get 3 pi over 2. Because basically 1 pi plus half a pi. So if I go to my graph and I go to 3 pi over 2, since that's in terms of 12, that's going to be 18 of these. So here's pi, there's 12, 13, 14, 15, 16, 17, 18. So right here is 3 pi over 2. Which is our number down here. And again, I just found that by adding our period to our phase shift. So my graph is going to end here. Now again, since it's in 12, so this is 6 pi over 12, and this was 18 pi over 12. So now the other cool thing about this is I can find the middle of this. So between 6 and 12 would be 12 pi over 12, which would be pi. So halfway in between would be here. So I'll mark that point. So that's 12 pi over 12. And then I'll go between 6 and 9, which would be 9 pi over 12. So 6, 7, 8, 9. Now this point's important because that's going to be up with the amplitude. So the amplitude's 1.5, so I'm going to go up there. And that's kind of part of my graph. So I started with this. I added pi to get this one. This was halfway. And then I'm basically just splitting halfway the other ways. So the same thing would be for here. So I could go down here, and that would complete my graph, because it'll go down there and up there. Okay? So there is my graph. Looks something like that. And then it would continue and go off like things like that. Now, since our final is a lot computer-based, a lot of the most important things will be able to find the period and the amplitude and the phase shift and the vertical shift. So graphing it not as important, because you can always graph these on a graphing calculator to see kind of what they look like. But these formulas are going to be invaluable to you, so you should definitely make sure you have those down. Okay, so the next question says, what is the equation that would represent the graph below? So first of all, if I'm trying to write this graph, I'm going to know it's going to be y equals something with x. So I notice this one starts at 0, so it's going to be some kind of sine wave. This will be one example of a thing you can have for it. Now the amplitude, I notice this goes all the way up to 3, so I'd put the number 3 in front. Now a normal sine wave starts going up and kind of does this, right? So this one is reversed. So what I do is I put a negative out front there to do that reversal. So now we've got it going to the correct height, it's doing the correct motion, and it's going the correct direction. Now all I have to figure out is how big the period is going to be. Now the period is from where this thing starts to where it starts to repeat itself. So if I go down, and then I go up, and then I go down again, it seems to repeat itself every 2 pi over 3. So the period is 2 pi over 3. Well, to write my equation, I need to figure out what the number I put in front of x here is. Well, if you remember from the previous problem, it said the period is always 2 pi over b. So in our case, b is obviously 3. Because if I want to get 2 pi over 3, I need to put a 3 on the bottom. So I can put a 3 here. So y equals negative 3 sine 3x is going to best represent this graph on the left. Now again, for all these graphing problems, just recall, you can always graph these in the Desmos calculator or any kind of calculator you have, just to get a general idea of what they look like. So if you got this an answer and you wanted to check it, you can just put it in the graph and see if it looks like this one. Okay, let's look at this last one. It says, which of the following is the equation of the graph below? And for some reason it says 5 points. So, if you look at this, you can really graph it to kind of see what it's going to be. But tangent, if you recall, it was a bunch of waves that look like this. So it's not tangent. Cotangent was a bunch of waves that kind of look the same, just kind of offset a little bit. So it's not tangent. So it's either going to be secant or going to be cosecant. And I would just graph it to see what it is. But I can tell you, you can check them. You should graph these two on your own. But I would tell you, it definitely has to be this one. And again, multiple choice graphs are really easy because you can just graph them and see, which one it's going to be. All right, so hopefully this is helpful for you as your first review for your final exam.